Let's talk about non-Newtonian fluids and how that relates to quicksand. This problem you thought you were going to have as an adult when you were a kid. Let's talk about this equation, which is how hard you pull on something is equal to this constant viscosity and how fast you're moving through something. Viscosity is basically friction for fluids, and the interesting part about it is that it varies for non-Newtonian fluids based on how hard you're trying to pull on something. With Newtonian fluids, that means like water, if you pull really hard on water, it becomes harder to pull on. So as you try to move your hand really fast through water, it gets harder to move it faster. With non-Newtonian fluids, with shear thickening and shear thinning fluids, that's not necessarily the case. It doesn't happen. So with quicksand, it's actually a shear thinning fluid. As you stand on quicksand, your weight pushes against the sand, and that makes it easier for you to sink into it. And this other example, which is oobleck, this thing made famous by Dr. Seuss, or given a name by Dr. Seuss, which is a cornstarch and water mixture. And the way it works is you suspend cornstarch in water, and it creates this shear thickening fluid. Let's revisit this graph we looked at earlier, and specifically look at the shear thickening and shear thinning fluids. So as you notice, they kind of curve off from the Newtonian fluid. What that means is, as we start moving faster through shear thickening fluids, they get much harder, much faster to go through. And in shear thinning fluids, as we try to go faster, it can actually get easier, or it doesn't increase nearly as fast. The reason quicksand is something that traps you is basically as you sink into it, you get stuck because when you struggle around in it, you knock it out of its suspension and it becomes just sand. So basically, quicksand is dangerous is because it's a shear thinning fluid when you're standing on it, and then once you're in it, it just is sand. So you're now buried alive. So now let's break down our experiment. We'll start off by mixing up our non-Newtonian fluid. Then let's get out our weight, which we actually move into the non-Newtonian fluid, and a counterweight. So that's just to create a force imbalance. And then we have a pulley. So let's start hooking stuff up. Put our weight in our non-Newtonian fluid, attach it to the pulley, tie up all of our counterweight, and attach it to the pulley. Now we have a force imbalance as a result of having more counterweight than we have submerged, and this means that we have this force imbalance that is the weight is going to create this shear force. So now let's actually run the experiment. We did it a bunch of different times, and what we ended up going with was that 2 counterweights and 6 counterweights showed a significant difference in the speed, specifically the non-Newtonian fluid. It's dramatically slower at 6 counterweights than it was at 2, which is really interesting. And to compare it against it, we also have a Newtonian fluid for water. So if you watch closely, it's going to go kind of fast, and the Newtonian fluids are actually at half speed because water's viscosity is just so much lower than the cornstarch and water oobleck that it had to be slowed down. But for comparison, you should be able to notice everything. Alright, that was it. So you see it? Hopefully you saw it as it went pretty quick, but you can see that the 6 weights went slower for the non-Newtonian fluid and quicker for the Newtonian fluid. That was the important part. That's it for us. Thanks for watching. If you liked, go ahead and press the like button at the bottom. It really helps. Last but not least, image citations for the PowerPoint in the first half. So thanks again for watching. Hope you enjoyed.